Hi everyone, welcome to the last section of Chapter 7, 7.6 Growth and Decay. So really what I've got for you for 7.6, we're going to use formulas. In 7.5 we graphed exponential growth and exponential decay, and now we're going to use formulas to actually figure out some word problems. So I've got 3 equations and 3 examples. So let's start off with exponential growth. So when something's growing exponentially, like in science class, bacteria or something like that, you might use exponential growth. So the formula is y equals a times the sum of 1 and r to the t power. Well, there's a lot of variables in there, so let's write down what all these things are. So the y value is your final amount. That's what we're looking for. Y is the final amount. Your a value is your initial or starting amount. I'm going to call it from here on out the initial amount, so I don't have to write out starting as well. But that's what you start with, your value. The r down here at the bottom inside the parenthesis is the rate of change. So if you're looking for a clue, that's going to be the percent in the word problem, but turn it into a decimal. Everybody knows how to turn a percent into a decimal, right? Move the decimal place back 2 places, add placeholders if you need to. Really what you're doing is you're dividing by 100. And that little exponent t up there is time, and it has to be in years. So if they told you 6 months, you'd put a half of a year. So it has to be in years. So our first example is about population. In 2008, the town of Flat Creek had a population of about 280,000 and a growth rate of 0.85% per year. First of all, they have to tell you that it's growing because that's kind of an important thing. It says write an equation to represent the population of Flat Creek since 2008. So first of all, 280,000. That's what the population was when we start this problem. So that's going to be our A value, our initial or our starting amount. And 0.85, big clue, right, is always going to be your rate. Look for your percent. It doesn't give us a time right now, so this first part A, we're going to have a t in there still. Part B, we're actually going to put a value in and solve it. So let's put in. So it doesn't tell us, we don't know what the final amount, so y equals our A value, 280,000, parenthesis, 1 plus r. Well, our R value was 0.85%. We need to turn that into a decimal, so move the decimal back 2 places or divide by 100. Feel free to go to your calculator and do 0.85 divided by 100. It will be 0.0085. And we're going to put that to the t power because it didn't tell us how long. So it's going to split it up like this and have you write 2. Part B, it's going to have us tell us how long, how many years we want to know. That's our answer to part A. We just put everything in the appropriate place. So the hardest part is reading that and figuring out what goes where. So part A, y equals 280,000 times the sum of 1 plus 0.085, all to the t power. Part B then, it says, according to your equation, so use your answer from part A, what will be the population of Flat Creek in the year 2018? Now, are we going to put 2018 in for the time? Because that's going to be really big. Look back at the original problem. When did they start talking about the population? They started talking about it in 2008, right? So how many years has it been that we want to know with the population? So we're going from 2008 to 2018. So what will we put in for our time, our t for our formula? So 10 years, not the year 2018, but 10 years that we want to know. So we're going to do y equals 280,000 times 1 plus 0.0085, all to the 10th power. Now it's calculator time. Think order of operations. You can do exponents, parentheses, or powers first. Parentheses, exponents, or multiply first. We're going to do parentheses, right, Pemdas? We've got 3 things to take care of. We've got parentheses, We've got an exponent to the 10th power, and then we're going to multiply. So this is what you're going to do. Go to your calculator. Type in 1 plus 0.0085. Your calculator will tell you this. Don't even clear it out. Use your exponent button. It usually, some of them are y to the x power, and some of them are just like a little up arrow caret. So do that 1.0085 to the 10th power. I don't know what that comes out to because I'm just going to take that answer and I'm going to multiply it by 280,000. 280,000. So parentheses, exponents, then multiply. When you get through that, you should end up with a population in the year 2018. Flat Creek will have 304,731 people. If you don't get that answer, please go back and do the math on your calculator again. Rewind me and listen to me talking you through that. It's all about order of operations. So these problems look pretty intimidating. The formula looks intimidating, but really the problem itself is not that bad once you put everything in the right place. So I'm always going to go through and I'm going to identify what part goes where so that we know. So our second equation, formula, is exponential decay. So we graphed exponential decay. We know it's going down. Our formula looks very similar. The only difference between this formula and the last one, inside the parentheses, we've got a subtract instead of an add. Everything else stays the same. So y is our final amount. A is our initial amount, or starting if you prefer. R is the rate. Make sure you turn that into a decimal. I feel like I've said this before. And T is the time, and it's got to be in years. Not what year it is, like 2016, but in years over the amount of this time. So the second problem is about charity. During an economic recession, times are going bad, things are losing money, or people are losing jobs and money. A charitable organization found that its donations dropped by 1.1% per year. Before the recession, its donations were $390,000. This is going to break down just like the last one. The first one wants us to write the equation. The second one wants us to put a value in. So 1.1% per year, what's that going in for? R, right? How about 390,000? It says before the recession. That's what we started with. So that's going to be our A. So let's write our equation, use that as your format. So y equals 390,000, parenthesis. I'm going to do 1 minus, don't forget it's a subtract for decay. It makes sense, right? If something's going down, we have to subtract. And our percent, 1.1%. So when we turn that into a decimal, move the decimal point 2 places and you get 0.011. And that's all to the t power because it didn't tell us how long yet. So there's our formula. Some people will go ahead and do the 1 minus 0.011. I figure the calculator can do that for me later. So part B, it says estimate the amount of the donations 5 years after the start of the recession. So guess what we now have? Our time. So when we go to evaluate this, we're going to do $390,000 times 1 minus 0.011 to the 5th power because we now know the time. So go to your calculator. Do parentheses first, 1 minus 0.011. I believe that will be 0.989. Do that to the 5th power. Remember, it's either y to the x or some calculators have an up arrow. Take that answer without clearing it out or retyping it and multiply by 390,000. And my final amount, my y equals, I got $369,016, and if we're being technical, 74 cents. So 5 years later, if it continues to decrease, they go from $390,000 in donations to $369,000 in donations because it's exponential decay. They're losing money or getting less money than previously. If you didn't get that answer from the calculator, you got your equation set up, make sure you talk to me so that we can work through the calculator part. Our last formula is compound interest. So compound interest, you guys may be affected by this and not even realize it. When you put money into a bank, it's sometimes compounded monthly or quarterly. Savings accounts are often compounded quarterly. So every quarter you get 1.2% or something like that. So first of all, our formula A equals P multiplied by 1 plus R over N, all to the NT power. It's a little busier than our last formulas. It is interest, so we are adding inside the parentheses, because remember, if they give you interest, it increases. If we pay interest, like on a car loan or a mortgage, we pay more, so it gets added on. So let's fill in our blanks. So A is our current amount. How much we have now. P was our principal or our starting amount. How did I put it? I'm going to put starting amount. Starting amount. Actually, I'll put principal in parentheses. We've got R up here on the top. We know that R is the rate. I'm going to do this. And turn that into a decimal. I don't have room to put that in there. Well, I guess I do. Decimal. The N on the bottom, this is the tricky one. The N on the bottom means the number of times compounded, and we're going to talk about this in this chart, compounded each year. Number of times compounded each year. Notice we have the N again, a repeat up at the top. So N is the number of times compounded, so you're going to reuse that number. And then we know T is time in years. I know it's a little crowded in there. I apologize for the crowdedness, but so first of all, compounded means how many times you're going to put interest in there. So if they compound the interest annually, how many times a year are you getting interest? Just one, right? Annually means they're doing that one time a year. If they compound interest every month on a monthly basis, how many times are you getting interest? Every month, well, how many months in a year? You're getting interest added on 12 times a year. I'm going to skip semi-annually for a second because we're on a roll. If they compound your interest weekly, which is very unusual, but how many times are you getting interest added on if they compound it weekly? 52 times a year. So this is your N chart right here. Semi-annually means that they're going to add on interest twice a year, every 6 months. Quarterly, how many quarters are in a year? So you get 4 times that interest is compounded. Every 3 months would be quarterly, right? And daily, I'm not meaning to be a trick question here, but typically, if it was compounded daily, you'd get interest 365 times in 1 year, unless it's a leap year. We don't need to talk about that right now. So, last example. When Paige was born, her very kind grandparents invested $1,000 in a fixed rate savings account at a rate of 7% compounded annually. Paige will receive the money when she turns 18 to help with her college expenses. What amount of money will she have from her investment? So let's figure out all of our stuff first. So I'm going to scroll down so we can see. This $1,000, her grandparents invested $1,000 in a savings account. Does everybody agree that that's got to be P, right? That's what our starting amount or our principal is. I've got 7%. Well, we all know what the percent is. That's going to be our rate. Here's a couple magic words right here. Compounded annually. So the compounding is our N. And what will our N value be if it's compounded annually? 1 time each year. She will receive the money when she turns 18. So if they invested that money when she was born, she gets the money when she's 18. How long is that money sitting in the bank? Time is 18 years, right? So I'm actually giving you the time. I didn't split it up this time, but we're going to do the same thing. We're going to set up the equation. We need to see the equation so that we actually know what you're setting up. So if it asks for what amount of money will she receive, we're looking for A, or the current amount when she is 18. So look at your paper. I know it's hard for me to, I'm going to scroll down so I can set up my formula, and then I'm going to scroll back up. So A equals, we don't know. P, our starting amount or our principal, is $1,000, parenthesis, 1 plus, and then we've got to do R over N. Well, our R is our rate, so, and we're going to turn that into a decimal, so I'm going to do 0.07 over N, how many times it's compounded each year. We said that was going to be 1. And that's going to be to the N times T power. So N was 1, reuse that, times 18. So here's my formula based on, here's my equation based on the formula. So now math, are you ready? First of all, inside my parentheses, because that's where I start with order of operation, well, 0.07 over 1 is just 0.07, right? So do this, 1 plus 0.07. Probably will end up being 1.07. Don't clear that out of your calculator. Raise it to the power. Do this, either do this math first or do it mentally. I hope you can do 1 times 18 mental math. So take your 1.07 from your parentheses to the 18th power. Get that answer. Don't clear it out. Don't write it down. Multiply by the 1,000 that is your starting amount or your principal. And when I did my math on my calculator, I ended up with Paige getting $3,379.93. It's not too bad. I'd take that. That could help out with college expenses. If you didn't end up with $3,379.93, please make sure you talk to me so that we know what the calculator issue is if you're struggling with those. But really, I can't see the work in the middle. I need to see the equation that you set up based on the formula, and then I know it's calculator math to get that answer. All right. Last thing. Summarize in your own words what this lesson is about. Tell me what you think. Tell me what it is. What do you see as the point or the idea? And here's a practice problem. Find the new account balance if $2,000 was invested at 8.5% interest compounded quarterly for 10 years. So this is going to be your compound interest, that last formula. So another practice with that one. And you've got the formula right on the same side of the page. What will be the new account balance? $2,000 was invested, so this is going to be our starting amount. This is going to be our rate, because we always know the percent. Compounded quarterly, look at that chart to figure out what your N is going to equal. And here's your time, 10 years. All right, ready, set, go. Last section of chapter 7.